Welcome to Physics, Work, Energy and Power. We have a mass of a trolley 1 kg, and that's the mass of a trolley, and the speed moving up, it's 3.5 meter per second. It's going up an inclined surface from point X to point Y, and the distance between X and Y is 1.5 meter. That's the distance. And then we have the height between X and Y, and that height there is 0.5 meter. That's the vertical height. And the question says, is the mechanical energy conserved? And explain. Yes, it is conserved. The reason will be there is no non-conservative force, so which means we don't have the force that resists the movement like friction, because remember they told us that it's frictionless, so there's no friction. So no friction, and we ignore the air resistance, the air drag, then that means we have mechanical energy conserved. So calculate speed of trolley at point Y. So the speed of trolley, we use conservation of mechanical energy, so that's mechanical energy at X is equals to mechanical energy at Y. And mechanical energy is kinetic energy plus potential energy. So all that potential energy and kinetic energy at X is equals to kinetic energy and potential energy at Y. So that's our point Y there. Mechanical energy there at Y and X is the same. So that's what we know. And then kinetic energy is a half mv squared plus potential energy is mgh1. So vi initial velocity and height 1. So it's gonna be half mass velocity final squared plus mass times g times height final. So we know that 3 meter per second, the final velocity initial is 3.5 meter per second, and then the final one we don't know. So v initial is 3.5 meter per second, and then we have mass there as 1 kg. That's 1 kg mass, and then we have gravitational force, that's 9.8 meter per second squared, and then we have height. Height 1 is going to be 0, that's the ground, so we take the ground as 0.0, and then height 2, so that's height final, that's going to be 0.5 meter. So that's what we have. So that's the information that we have. And then we need to calculate the final velocity. So we substitute mass is 1, initial velocity is 3.5 squared plus mass is 1 and g is 9.8 multiplied by height 1, initial height is 0 plus half mass 1, final velocity is what we don't know, plus we have mass 1, 9.8 for gravitational acceleration, and then we have initial height as final height as 0.5, and then what we simplify that's going to be 3.5 squared divided by 2, that's 6.125, so that's going to be 6.125, and that gives us 0. 0 times 9.8 times 1 is 0, and then that half of that's going to be half v final squared, and then that is going to be plus half of 9.8 is 4.9, so it's going to be 4.9, and then we have half v final squared is equals to, we have 6.125, we take the 4.9 to the left side, it's going to be negative, so 4 goes that side, 4.9 becomes negative 4.9, and then we simplify further, that's half of v final, that's going to be 6.125 minus 4.9, giving us 1.225. from our calculator. So it's 1.225, and then multiply both sides by 2 to cancel out. So multiply by 2 there and multiply by 2. That will give us v final squared is going to be 1,225. Multiply by 2. So we didn't actually multiply by 2. Plus or minus square root of 1,225. Squaring that one, we didn't multiply by 2, so multiply by 2 there. That will give us, it will give us 2.45. So 2.45 okay, then therefore we square root that. That's going to be 2.45. Square root of that 2.55 becomes 1.56527. So it's going to be 1.567 and then meter per second. That's our answer. Step 1, step 2, step 3, simplify and so forth. So have step 4. So all of these are simplifications. As long as you get the first equation right and then you expand it and substitute, then you arrive at the final answer. And then let's go to the last question, which is C. So the last question, C, states that okay, suppose that you have x and y, now it's a rough surface, and will it reach point y? That's what it wants to know. So we have a rough surface now, and do you think it's going to reach point y? So we have friction there as 5 Newton, 5 Newton our friction. So that means that work done, we use work done by non-conservative force is going to be change in kinetic energy plus change in potential energy. So that would be from there, friction is 5 Newton, and then we have our trolley there. So we want to know what the displacement would be. 5 multiply, I think it's 5 change in x multiplied by cos. We don't know the horizontal part that is going to play, but it's for 1.5 meter. It has to be less than 1.5 meter because of the friction. So I don't think it's going to reach point y, but then we just need to explain. And then its cos is 180 degrees because it's opposite motion, direction of motion. So it's going to be half. Mass is 1, and final velocity has to be 0 where it stops, the distance where it stops, and then minus initial velocity, which is 3.5, and we square that, plus it's going to be mass 1, g is 9.8, and then the difference of the height, which is 0.5, the final height minus initial height, which is 0. And we know that change in kinetic energy is half mv final squared minus v initial squared, and then change in potential energy is going to be okay, that's that part there, that's the change in kinetic energy, the part that we just solved, and then that's mg multiplied by difference of the height, and then that's that part there that we just substituted. That's the potential energy part. So yeah, I think we have to crash that. I don't know when that I double entered that. So that's work done by non-conservative force. So work done by friction, that's not a non-conservative force, is friction. And then that's it. From there we have to simplify. That's going to be cos 180 degrees is -1. That part there, 0 minus that's gonna be negative, and then 3.5 squared with the 9/4, and then half of that is 6, that's negative 6.125. And then here we have that part there, that's gonna be 0.5 times 9.8 is 4.9, and then we have -5. Change in x is equals to the difference of the two, -6.125 plus 4.9 gives us negative 1,225. Yeah, so changing x there is going to be negative 1,225 divided by negative 5. So that gives us a positive value that's going to be 0.245. So that's when you use a calculator, and then that will be 0.25. Yeah, so it's going to be 0.25 meter. So that's our final answer. And then the answer is no, it won't reach 1.5 distance, so it's going to end somewhere there at 0 because of the friction, 0.25 meter. So that's where it's going to end. Yeah, thank you so much for being with me and listening to all the solutions that we have. And if you have any question, don't hesitate to leave behind. And this is your tutor, Black Adam 5D tutor. And don't forget to follow or subscribe. And if you have any question, you can comment below and I'll come back to you. Any problem, you can email on the email provided on the channel. Thank you so much for watching, and don't forget to follow or subscribe. And that's it. So the basic thing is follow the procedures, the principles of energy, substitute correctly, and then finally you get it to the right point. Thank you.